Hello, so this is going to be your gas laws lab prep, okay? And I'm going to kind of talk you through it to see, or so you know exactly how to prep your lab notebook for this lab. Okay, so instead of me giving you the long, I did give it to you and you can read it if you want to. It's a link on your first slide for this lab. But I kind of broke it down because the way that the lab is set up is a little confusing. So I broke it down to where it makes it easier for you to understand. So the purpose of this lab is to explore the relationships between pressure and temperature and pressure and volume. So we're looking specifically at Charles' law and Boyle's law. In this lab, I will also learn how to graph my data appropriately for data analysis. So this is going to be the first time that we're going to use Google Sheets to kind of analyze our data for us. Okay, what are our concepts that we're talking about? We're talking about pressure conversions because we're going to go from kilopascals to atmospheres, graphing in Google Sheets, and then the relationship between pressure and temperature, and that it all should say the relationship between pressure and volume. So those are our four concepts that we're dealing with this lab. Okay, so there's two different procedures. So obviously, since we're doing pressure and volume, that's procedure one. And then pressure and temperature, that's going to be procedure two. So you're going to have two different procedures in addition to two different data tables. Okay. So the first thing that we're going to do is we're going to attach a 20 milliliter syringe near the midpoint. So what I'm going to do is I'm going to pull the syringe back to 10 milliliters and then attach it to the gas pressure sensor. And you'll see how I do that. That way there's a little bit of air that is going to resist the probe being pushed in. So we'll be able to get an accurate pressure. And then what we're going to do is we're going to record the pressure and volume for at least 7 different volumes. Okay, I'm not giving you which volumes you have to do, but when we actually get into the lab, we will collect 7 different volumes. And then what we're going to do, and I'm going to help you with this through a data analysis, is we're going to convert the pressures from kilopascals to atmospheres and volume from milliliters to liters. And we're going to do this in Google Sheets because it saves us a ton of time instead of us converting each one individually with a calculator. And then we're going to graph. We're going to do pressure versus volume to see the relationship. And then we're going to change it to 1 atmosphere, 1 over atmospheres versus liters. And when I do data analysis, we'll kind of talk about why we did that. Okay, so that was the first procedure. The second procedure is we're going to do pressure and temperature, okay? So the first thing that we're going to do is fill a 250 milliliter, it should say beaker, sorry, with around 300 milliliters of just tap water, okay? We don't need distilled water for this. We are then going to place the beaker on a hot plate to prepare hot water because since we're changing the temperature, we need hot water and cold water, right? We're going to set up an Erlenmeyer flask and water with a gas pressure probe attached in addition to a thermometer, okay? So you'll see that I have a flask here. Obviously, the only thing that's going to be in that flask is air, right? Because that air is a gas, so we're dealing with just the air. And then I'm going to put a stopper over top of it, and you'll notice that it's hooked up to a pressure sensor. So as the pressure changes in here, it's going to give us a readout here. And then in order to record temperature, we also need to have a temperature probe, which we're going to use a temperature probe instead of a thermometer, in the water so we can record what the temperature is actually changing to. And then we're going to add ice to this beaker, right? So we're going to start it off at near 0 degrees. We're not going to be able to get to 0 degrees. Sometimes I can, sometimes I can't because it's ultimately not fully frozen. However, we can try. So that's that. So we're going to start with cold water. And then the next thing we're going to do is we're going to increase the temperature by trying around 5 degrees Celsius by adding the hot water that we are warming up on the hot plate. Sometimes I can do 5 degrees, sometimes I can't. It just depends on how good everything's working for me. And then we're going to record temperature and pressure readings. And again, a minimum of 7. However, I find that the temperature and pressure lab works better data-wise if we collect more data. So once I get into the lab to do this, we'll see how many I'm actually going to take. And just like we did with the other one, we're going to have a data analysis that's going to look something like this. So we're going to convert degrees Celsius to Kelvin in Google Sheets. We're going to convert kilopascals to atmospheres in Google Sheets. And then we're going to graph atmospheres over Kelvin, okay? Now we're going to extrapolate the data, which means we're going to add a data point that we know by definition to our graph to make it look better, right? Make our linear line better. And that point is going to be 0 Kelvin is equal to 0 atmospheres. Why? Because 0 Kelvin is a theoretical temperature that we haven't reached yet. But what 0 Kelvin is telling us is that there is absolutely no movement of the particles. And if the particles are not moving at all, they're not going to exert a pressure on the container. So therefore, they will have 0 atmospheres or 0 pressure. Okay? And so we're going to extrapolate our data to do that. And then we're going to graph pressure over temperature versus Kelvin. And I put 2 question marks there because you're probably thinking to yourself, didn't I just do pressure versus temperature in Kelvin? Doesn't really make much sense. But what we're going to see here is that we are going to get something that's going to help us solve for how many moles of air we have in our vessel. Okay, so our data tables. So again, like I said, you're going to have 2 different data tables. So for the first data table, we're going to have, I did 6 readings. 7, it should be 7 readings, sorry. You need the volume of the syringe and the pressure of the syringe for each reading. So that's what your data table should look like. And then when we analyze the data, this is what we're going to do. We're going to graph pressure versus time. Graph pressure versus volume in Google Slides. Oh my gosh. It should say Google Sheets. I'm so sorry. And then we're going to graph volume versus 1 over atmospheres, also in Google Sheets. We are then going to record slope of the graph and the intercept of the graph. And then we're going to talk about what each of those means for us if we think about the equation of a line. And then we're going to calculate the moles of air using Pivnert. And then think about what the slope of the line here is. And we'll talk about that a little bit more when we do data analysis. All right, second procedure, second data table. Again, you should have at least 7 lines here for your readings. And we're doing temperature at degrees Celsius and pressure at kilopascals again. And then our analysis here is we're going to graph temperature versus pressure. We're going to record slope of the graph and the intercept of the graph. And then we're going to graph pressure over temperature versus temperature and think about why should the slope be 0. Okay. So I want you to kind of think about that for a little bit. And then lastly, once we analyze, we're going to write our conclusion where we're going to say the purpose of this lab was, so you restate the purpose. I achieved this by, how did you achieve the purpose? And then we're going to do 2 sources of error, okay? There's not going to be any % error for this lab because there's no way physically that I can tell you how much gas is actually in the vessel. Okay, so that's it for your lab prep. Thanks for watching.